On the month of May 1980, an American physicist by the name of Paul Benioff proposed an idea. Together with his research in quantum information theory during the 70s, he demonstrated the theoretical possibility of quantum computers through his model. Many scientists before him claimed that this was impossible, but unbeknownst to the whole world, he had just set in motion one of the most elaborate technological progress the world has ever seen. What made Benioff's proposal click and ultimately cement himself as one of the pioneers of quantum computing was his reversible model of a quantum computer, meaning it did not dissipate energy. At that time, there were several papers arguing against the possibility of creating such model, but Benioff's paper was the first to show that the reversible quantum computing model was theoretically possible. This work, along with the later work of several other authors, David Deutsch, Richard Feynman, and Peter Shor, they initiated the field of quantum computing. Building on the work of Benioff and Feynman, Deutsch proposed that quantum mechanics can be used to solve computational problems faster than classical computers. This marked the day where quantum mechanics were applied practically to computing. In 1944, Shor expounded on the study and described a factoring algorithm that is considered to have an exponential speedup over classical computers. This will later be aptly called Shor's algorithm, well known in cybersecurity as the algorithm that could defeat cryptography itself. The immediate concerns and the security threats this fact poses is certainly questionable, and deservedly so. For a while, scientists were hesitant on making the quantum computer, knowing full well it may bring down the entire system of cryptography built on classical computers. But because of these exact concerns, it has also facilitated research on new crypto systems that are secure from quantum computers, collectively called post-quantum cryptography. It won't take until the early 2000s and up to the last decade that the race for the development of quantum computers began. The quantum computers that were developed utilized the so-called quantum bits, or qubits for short. Compared to the classical ones and zeros, or bit of the classical computer, qubits, however, operate in quantum superposition. Complicated quantum mechanics aside, this basically enables the computer to have both states at once, both 1 and 0 at the same time. Only when it is measured and observed will it output either 1 or 0. This sets apart quantum computers between classical computers. And as you've guessed, more qubits means more power. The first 5-qubit NMR, or nuclear magnetic resonance computer, and the first 7-qubit NMR computer was developed and demonstrated in the Technical University of Munich and in the Los Alamos National Laboratory respectively in the year 2000. Later on in 2006, the Institute for Quantum Computing and the Perimeter Institute for Theoretical Physics in Waterloo, as well as MIT Cambridge, benchmarks the first 12-qubit quantum computer. The last decade only further accelerated the progress of how many qubits could fit inside a quantum computer, mostly thanks to IBM's great interest in the field. One year it was 14, and then the next 53, then 100, and then 1,000. In fact, most recently in 2019, IBM announced the very first of its kind, IBM Q System 1 commercial quantum computer, although it would only hold a minuscule 20 qubits for now. Even today, quantum computers sees an exponential rise in innovation and progress, with the computer chip demanding more and more processing power, whilst not being able to become any more smaller. Quantum computing might just be the workaround for this limitation we have. To this date, many practical applications for quantum computers become more and more apparent to us, and they will all the more be essential for computing needs looking forward. Who knows what the future of quantum computing will bring, what kind of new opportunities and challenges it will present. But one thing's for sure, it will certainly be faster than today.